Humans, it's time for some quantum cat wisdom. Today, we're diving into operators and observables, two concepts in quantum mechanics that sound fancy, but are actually just like, well, me doing my daily cat activities. Trust me, if you understand how I operate, you'll understand quantum mechanics. Let's begin. Picture this. You walk into the kitchen and see me sitting innocently on the counter, staring at a tuna can. What's happening here? Well, you've just made an observation. In quantum mechanics, anything you can measure, like my position, velocity, or tuna thieving potential, is called an observable. But here's the twist. I'm not just there on the counter. I'm everywhere in the kitchen, in all possible states, under the table, in the snack drawer, maybe even teleporting onto the fridge. That's quantum mechanics. When you measure me, i.e., when you look at me, the universe says, okay, fine, Max is on the counter. Before that, I was a fuzzy cloud of probabilities. Observables collapse possibilities into a single reality. Now let's talk about operators. Think of these as the tools you use to figure out what I'm doing. In quantum mechanics, operators act on the state of a particle, like a wave function, to give you an observable value. Here's an example. Imagine I'm pawing at a jar of treats. You want to know how fast I'm moving. In quantum terms, you apply the momentum operator to my state. Boom! It spits out my momentum value. Max is moving at 10 paws per second. Or maybe you're wondering, where is Max? For that, you'd use the position operator. Apply it to my state and you get Max is under the table, plotting his next move. See? Operators are just mathematical ways of extracting information about me, or particles, if you insist, from the quantum world. But here's where things get interesting. Operators don't always play nice with each other. For example, if you measure my position, you can't simultaneously know my momentum with perfect precision. It's called the uncertainty principle. It's like this. If you catch me mid-pounce, you know exactly where I am, but you have no clue how fast I'm moving. Or if you see me streaking across the room at turbo cat speed, good luck figuring out exactly where I started. Quantum mechanics is sneaky like that. Operators are like my claws and my tail. They work together, but not always in harmony. Let's put it all together. Observable. You want to know if I'm on the counter. Operator, you apply the position operator to my state. Result. Congratulations, I'm busted on the counter, pawing at the tuna can. Or maybe, observable, you want to know how fast I'm chasing the laser pointer. Operator, you apply the momentum operator. Result, Max is moving at warp speed and there's no stopping him. See? Operators and observables are just tools and measurements. They let us understand the quantum world, or in this case, the quantum cat world. In quantum mechanics, operators and observables turn possibilities into measurable reality. Without them, you'd never know if I was napping in the sunbeam or plotting my next snack heist. But with them, you can peek into the chaos and extract just enough order to make sense of it all. So remember, humans, the next time you see me, I'm not just there. I'm an observable, shaped by the operators of the universe. Now, if you'll excuse me, I need to apply the tuna operator to my snack situation. Class dismissed. Don't forget to subscribe, humans, because observing me is the best way to collapse your boredom into pure entertainment.